Okay, so for part B, the function is fx equals to x squared minus x, and a equals to 2. So let us consider the second definition. So f prime of 2 is limit x tends to 2 of fx minus f2 divided by x minus 2. Okay, and in this case, I will have limit x tends to 2 of x squared minus x, and f2 is, I substitute x by 2. 2 square minus 2 is 2. I have this one, x minus 2. Okay. Of course, the numerator can be written as the product of x minus 2 and x plus 1. Okay. So I have x squared plus x minus 2x, so x squared minus x minus 2 divided by x minus 2. So I have limit x tends to 2 of x plus 1. Okay, this limit is 3. Okay, simply put substitute x equals to 2. All right. Okay, any question up to this point? Any question so far? Okay, is it clear? Okay, so the next one, C, the function is 3 over x at a equals to 3 over 2. So f of x equals to 3 over x and a equals to 3 over 2. Then we want to calculate f prime of a, or f prime of 3 over 2. We can use both definition. So let us use limit x tends to 3 over 2 of fx minus f at 3 over 2 divided by x minus 3 over 2. Okay, in this case, we have limit x tends to 3 over 2. We have 3 over x minus f3 over 2, which is half. Okay. Then we have x minus 3 over 2. Okay, so let us simplify this. So we'll have, okay, probably simplify this expression, limit x tends to 3 over 2. Okay, so okay, let us consider the numerator here. The numerator will becomes okay, something like 6 minus, okay, right? Yes, it seems like a mistake, right?
Yeah, it's 3 divided by
3 over 2. So it should be 2, right? Okay. All right. Okay. Okay, so if we consider this, then we'll have, we simplify this term, have 3 minus 2x over x multiplied by 2x minus 3, all of this divided by 2, and right, 2x minus 3 divided by 2, okay, 3 minus 2x over x, right? Right. Okay, it's correct until this point. Now, you'll see that 3 minus 2x divided by 2x minus 3 is just minus 1, right? So limit x tends to 3 over 2. This one divided by this one is minus 1. So we have minus 1 over, or minus 2 over x. And then just put x equals to 3 over 2 then. Minus 2 over 3 over 2. And that will be minus 4 over 3. Right? Is it clear? Any question or comment up to this point? Okay. So for number 3 here, 3 and 3b actually quite straightforward. It's also 3b is similar to 2a. So let us now focus on 3c and d, right? Okay. 3c and 3d. Okay, for 3c, 3c, here I will have fx equals to square root of 3x plus 5. Then we want to know what is f prime of x. Okay. Yeah, actually it's it will be easier if we consider the chain rule later on, but now let us focus on the definition of the derivative. So here we use limit h tends to 0 of fx plus h minus fx divided by h. Okay, so in this case, we have limit h tends to 0 of square root of 3x plus 3h plus 5. Okay, just simply substitute, replacing x by x plus h there. And then this is square root of 3x plus 5, okay, divided by h. So the idea is to multiply it by its conjugate. So its conjugate is 3x plus 3h plus 5. Probably we'll need quite a lot of space here. 3x plus 5 multiplied by square root of 3x plus 3h plus 5 plus square root of 3x plus 5 divided by the same number. Okay, after multiplying by this one, then we'll have limit h tends to 0. The numerator becomes 3x plus 3h plus 5 minus, in the bracket, 3x plus 5, and then we have h, and then square root of 3x plus 3h plus 5 plus square root of 3x plus 5. Okay. And in this case, of course, the numerator becomes 3h, right? 3h divided by h. Then we get 3 only. Square root of 3x plus 3h plus 5 plus square root of 3x plus 5. Okay, so in this case, taking the limit h tends to 0, we have 3 over 2 multiplied by 3x plus 5. That's the Yeah, because if I take the limit as h tends to 0, this one is the same as this one. Okay. So I get 2 square root 2 multiplied by square root of 3x plus 5. Okay. Any question or comment? Yes, is it clear? Yes. Part C, yes. Minus 4/3. Okay, any question or comment? Okay. Okay, so for part D, we have sine 2x. Yeah. 3D, we have fx equals to sine 2x. So f prime of x equals to limit h tends to 0 of fx plus h minus fx divided by h. So in this case, we have limit h tends to 0 of sine in the bracket 2x plus 2h 2x plus 2h minus sine 2x divided by h. And the idea is that we expand this system. We know that sine 2x plus 2h equals to sine 2x cosine 2h plus cosine 2x multiplied by sine 2h. Okay, if we use this identity, then we'll have the last term equals to limit as h tends to 0. Okay, so I will put this expression, this one. So equals to sine 2x cosine 2h plus sine 2h cosine 2x minus sine 2x. Divide all of this divided by h. Okay, and we can write this as limit s tends to 0 sine 2x multiplied by cosine 2h minus 1 divided by h plus cosine 2x sine 2h over h. Okay, and then the limit here is taken for variable h. So sine 2x and cosine 2x here are constants. So sine 2x multiplied by limit h tends to 0 of cosine 2h minus 1 divided by h plus cosine 2x multiplied by the limit as h tends to 0 of sine 2h divided by h. And in this case, in this case, the limit here is 0. And in this case, the limit here is equals to 2. Okay. So in the end, we have sine 2x multiplied by 0 plus cosine 2x multiplied by 2. So we get 2 times cosine 2x. That's the derivative of sine 2x. Okay. Any question or comment up to this point? All right. So Now, okay. Any question or comment? Okay, so number 4 is actually the reverse process of number 2 and 3. Given a limit, then we want to find what is the suitable function f and what is the suitable function a, such that this limit is f prime of a. Okay. So for number 4a, the limit, okay, we want to find f and a such that f prime of a equals to the limit x tends to 1 of x to the power 5 minus 1 divided by x minus 1. Okay, so in this case, what is the function f? Fx equals to, in this case, fx equals to, from the definition, fx equals to, what is the formula for fx? X to the power of 5, right? And what is the value of a in this case? A equals to 1, right? A equals to 1. Okay. All right. Actually quite simple. For b, here, again, f prime of a equals to limit x tends to 4. And I will have square root of x minus 2 divided by x minus 4. Square root of x minus 2 divided by square root of divided by x minus 4. So the idea is here, for example, if you consider this one is fx minus f1 divided by x minus 1. Okay. So in this case, what is the formula for fx? Square root of x, and a equals to 4. Okay, a equals to 4. Okay. For number 11, sorry, number 11, number 4c, I have x squared plus 3x divided by x plus 3. X squared, so fx is quite f prime of a equals to limit x tends to minus 3 of x squared plus 3x divided by x plus 3. Okay. Okay, what is the value of the formula for f? Or what is the value of a here? A equals to minus 3, right? Okay. And then what is the formula for fx? So actually, one way to do that is to write this as x minus 3 in this case. Okay. So a is minus 3. And then here we have fx minus fa. So we have fx minus f minus 3 is x squared plus 3x. Okay, but what happened if I substitute x equals to minus 3 here? I have minus 3 squared plus 3 minus 3 is 0, right? So actually, it's written as here, it's written as, okay, so the limit becomes, okay, I will write the limit here is actually can be written as x tends to minus 3 of x squared plus 3x divided by x minus 3 and then minus 0. And 0 here is actually f minus 3. So in the end, fx equals to x squared plus 3x. Okay. Is it clear now? Is it clear? So here the 0 is actually f minus 3. All right. Okay, so the next one, D. Okay, so this is the alternative definition of f prime of A. So f prime of A equals to limit h tends to 0 of 5 over 2 plus h square minus 5 over 4 divided by h. Okay, right. Okay, so recall that f prime of A equals to the limit h tends to 0 of fa plus h minus fa divided by h. And what is the value of a in this case? If you compare these two terms, then a equals to what is the value of a? A equals to 2, right? And then fx equals to, so if fa is here, fa plus h, so it's obviously fx equals to f over x squared. Okay. Any question or comment? Okay, so number E for E. Yes. Just compare this. This one is a plus h. This one is 2 plus h. Should be a equals to 2, and x equals to 5 over x squared. And then if I substitute here a by 2, and then the formula for fx is 5 over x squared is just 5 over 4. Okay, is it clear? Is it clear up to this point? Okay. Part E, we have limit h tends to 0 cosine. So f prime of A equals to limit h tends to 0 of cosine 3h plus minus 1 divided by h. Here, what is the value of A? And what is the function of f of x? Okay. So again, you just realize this as fa plus h. This one is fa. Okay. So you may start from the function itself. So you'll see that perhaps we have cosine 3x here and a equals to 0. Because if you calculate limit h tends to 0 of f a plus h minus fa divided by h, this becomes limit h tends to 0. Fa plus h is a0 is cosine 3h. So cosine 3x when x equals to 0, cosine 0 is 1. So you get this one. This one is the same one. So fx equals to cosine 3x, and then a equals to 0. Okay, is it clear? Okay. Now part F. We have limit h tends to 0 of 1 plus h square minus 1 plus h over h. Limit h tends to 0 of 1 plus h square minus 1 plus h divided by h equals to f prime of a. What is the function f, and what is the point a? You may guess that a equals to 1 there. And then what is f of x? X squared minus x, right? Okay, so you'll see that again in this case fa or f1 equals to 0, right? Okay, so actually if you write this as limit h tends to 0 of f a plus h minus fa divided by h, limit h tends to 0 of a equals to 1, so 1 plus h square minus 1 plus h, and then minus 0 divided by h, because f at 1 is always 0. Okay. Okay, any question or comment? Okay, if it's clear. Okay, so let us consider number 5 here. So first, please read the statement of number 5. So number 5, a ball is dropped from a height of 80 meters, and the height of the ball in meters as a function of the time t in seconds is expressed by the formula h of t equals to 80 minus 5t squared. So the question is to calculate the instantaneous velocity of the ball as t equals to 1, and then we want to calculate the instantaneous velocity of the ball as it hits the ground. Okay, so that's the question. All right. So okay, we will calculate this by, oops, where is this? We will calculate this by calculating the limit here, limit in the definition of the derivative. So start with h of t equals to 80 minus 5t squared. So the velocity at instantaneous velocity at 1 is simply just h prime of 1. And in this case, by the definition, we have limit as t tends to 1 of h of t minus h of 1 divided by t minus 1. Okay. So in this case, we know that limit t tends to, limit t tends to 1, ht is 80 minus 5t squared. And what is h1? h1 is 75 divided by t minus 1. Okay. Okay. And in this case, we have limit t tends to 1 of 5 minus 5t squared divided by t minus 1. Okay. Of course, the last term, okay, the numerator can be written as 5 or minus 5 of t squared minus 1. Okay. Or I can write it as t minus 1 multiplied by t plus 1 divided by t minus 1. And of course, t minus 1 here cancel. And we will have h prime of 1 equals to minus 5. We put it outside the limit. Limit t tends to 1 of t plus 1. And we have minus 5 multiplied by 2, and that will be minus 10, right? Okay. Okay. Is it clear? Just applying the definition of the derivative. And the next one, we need to find what is the instantaneous velocity, but the time t is not given. And actually the time t, we have to look for the time t, and the hint is when the ball hits the ground. The meaning is that we want to find t such that h of t is 0, right? Okay, so we want to find t such that h of t is 0. Okay, so for part B, we need to find the solution of the equation h of t equals to 0. And then we have here AD minus 5t squared equals to 0. So here t squared is AD over 5, and that will be 16. So t equals to, since t is a time, so it's always positive. So t is 4, right? And in this case, we want to look for h prime of 4. Okay, h prime of 4 equals to the same as before. Limit t tends to 4 of h t minus h of 4 divided by t minus 4. Obviously, h of 4 is 0. So we have h prime of 4 equals to limit t tends to 4 of h of t is 80 minus 5t squared minus 0 divided by t minus 4. Okay, the same as before, we can write this as minus 5 multiplied by the limit t tends to 4, okay, of t minus 4 multiplied by t plus 4. Okay, so minus 5 here becomes minus 5 multiplied by t squared minus 16, and t squared minus 16 can be written as the product of t minus 4 and t plus 4. 5 divide this, then we have minus 5 of the limit t tends to 4 of t plus 4. Okay, and in this case we have minus 5 multiplied by 8, and that will be minus 40. Okay, so the instantaneous velocity as the ball hits the ground is minus 40. Okay, the minus sign indicate that the ball moves downward. Okay, all right, any question or comment? Okay, so let us continue for number 6. Actually, this is not so much calculation, but only the observation here. So we are given the graph of the function, okay, and okay, the function at the point A, B, and C, and then if we zoom in the picture, then we get the point A, B, and C, okay, as follows. And okay, so the question is, we want to find we want to approximate the gradient, okay, of the tangent line to the graph at the point A, B, and C. Okay, and here you see that what is the gradient of the first line? The gradient is 0 because you'll see that the tangent line is horizontal, right? And then what is the gradient at the point B? So for point B, the line moves 2 units to the right and 2 units downward. So the gradient is minus 1. The gradient is minus 1. Okay. And how about C here? So C here is approximately 2 units to the right, and then 1, 2, 2, 2, 6 unit upward, right? So the gradient should be 3, right? Okay, you just calculate the box here, the square in this case. Is it clear? Okay, so the first one, the gradient is 0. The second one, the gradient is -1. And the third one, the gradient is 3, right? Okay. So number 7, here you are given the graph of the function and the graph of their derivatives. Yes? Okay, okay. Okay, so number 7, you are given the graph of the function and then the graph of their derivatives. Now, you have to match the graph of the function and the graph of the derivatives. For example, 7a here, small a, you'll see that the function here is a linear one, and then piecewise linear actually. So you'll see that here is a line with the some gradient, and then continue with the horizontal line. Okay, so in this case, you'll see that the derivative of this function should be a constant, should be the two constants, namely the gradient of this line, and then the gradient of this line, and then the gradient of this line is 0. Okay, so you have to take a look at this case, which one is where the value is 0, or the value is a constant, positive constant here. Which one? A, B, C, D, E, or F? The answer is D here. So you'll see that here, if you take a look at the gradient of this line should be M is positive, and then the gradient of this line M is 0. And the gradient of the line here representing the derivatives. So in this case, it's a positive constant here, and then it's 0 there. Okay, so the function, the graph of the function A here, that its derivative is this function. Okay, so A is corresponds to D here as the derivative. Is it clear up to this point? Okay, so we continue. Now, the second function is okay, still piecewise linear here, but now you'll see that, yes, question. Okay, for B, you'll see that the gradient is here is a negative, positive, negative, positive, negative, positive. Okay, and it's a constant. So negative, positive, negative, positive. So which one from the A until F here? Of course, it's not D. Which one? It's a constant, and its sign are always alternating. Positive, negative, negative, positive. That will be F, right? The answer is. So you'll see that negative, positive, negative, positive, negative, positive. Okay. The answer is F. So the function B corresponds to the derivative is F. Okay. All right. So now let us consider the function in C here. So the idea is that if you draw the tangent line here, okay, something like this one, okay, and at a certain point, the gradient is 0, right? And from positive, 0 and then negative here. So you'll see that from this picture, which one? Positive, positive, 0. So which one? So of course, yeah, because it's the gradient in the okay, when x is positive, the gradient of the tangent line here is negative, right? The gradient of the tangent line here is negative, so should not be A, C. So the candidate is only B and E, right? But you'll see that here the gradient is when x is very large, the gradient is approaching 0. Okay, so you'll see that the correct answer should be C, correspond to B, right? Okay, so here and then 0, so C corresponds to here, C correspond to B, right? Okay, all right. So the next one, D here. So you'll see that the gradient of the tangent line is as follows. So it's on when x is negative, the gradient is negative and it approaches to minus infinity, right? And then here I have a positive gradient. Okay, so in this case, which one should be C, right? Okay, when the gradient is negative, we have the negative derivative, and then when the gradient here is positive, then we have the positive derivative. Okay, should be D correspond to C. Okay. Okay, so now here, this is the gradient tangent line. So C correspond to, it's always positive, because you'll see that the tangent line is always, the gradient of the tangent line is always positive, and it's increasing up to some point, and then okay, some constant, and then decreasing. The slope from increasing and then decreasing. So the for E here, what is the suitable derivative? E correspond to A, right? Positive, it's always positive, and you'll see that it's increasing and then decreasing. Okay. All right. So F should be E, right? It's the remaining answer. Okay. But you may also consider this. The gradient is positive, 0, and then negative up to approaching the minus infinity. All right. Any question or comment? Okay, before short time break, we will consider number 8 here. Given the graph of the function f, the question is to find all points in the domain of the function such that the derivative of f does not exist at that point. Okay, so the answer quite easy, because okay, first you'll see that the differentiability, or the function f is having derivative, implies the continuity. Okay, so if f prime of c exists, then f is always continuous at the point C. Okay, so the case where the derivative does not exist here, of course, the obvious choice is the point where f is not continuous. And in this case, f is not continuous at -2 and -1. Okay, so you'll see that at -2 and -1, obviously, the function f does not have derivative. And then, okay, of course, we have to check another point. And you'll see that at 2 here, you'll see that the function does not have the tangent line, because if you take a look at the graph of this, then to the left of 2, it seems that the tangent line is x-axis, or the y equals to 0, but to the right of 2, we have the following line. Okay, so you'll see that the left-hand limit and the right-hand limit in the definition of the derivative are different, right? So here, the reason is that if you consider limit x tends to 2 from the left of fx minus 2 minus f2 divided by x minus 2 not equal to the right-hand limit of the same function. Okay, this one. Okay. So the limit here at 2 does not exist, so the function f does not have derivative. Okay. Or you may take a look at the interpretation geometrically as the shape of the graph of f here looks like the non-smooth turnaround here. Okay, because you turn to this one, should be something like this is if the derivative exists, but if the turnaround here is not smooth, then obviously the function does not have derivative at this point. So the conclusion here, the derivative of f does not exist at which one? Can you mention the point? -2, -1, and 2. Okay. Any other point? Any other point? It's not that clear, but actually you'll see that here at 1, the gradient of the line here is a vertical. So actually you'll see that the function also does not have derivative at 1, 1. Okay, at x equals to 1. Okay, so in total, the function does not have derivative at -2, -1, 1, and 2. Okay. All other point, the function have derivative. Okay. Okay. All right. So we will take a break for a moment, and then we'll continue to number 9, 10, and 11, so forth. Okay. I will pause the recording. Okay, so let us continue. So number 9 here, you are given a 3 function here, and then the question is to check whether the function has a derivative or not by considering the left-hand limit and the right-hand limits in the definition of the derivative. And actually, before we consider the calculation, so let us take a look at the picture or the graph of this function. Yes, for example, the graph of f. Yes, I haven't put the screen. For example, if you consider okay, so the first function here, I will repeat. The first function is absolute value of x squared minus 1, and then the point given here is at a equals to 1. Okay, so let us take a look at the picture of the absolute value of x squared minus 1. Okay, something like this. And you may guess that at this point, the function does not have derivative, because if you take a look at the picture by the tangent line, if you see that to the left of 1, you will get something like this, but to the right of 1, you will get something like this. Okay, so it does not have a tangent line at this point. Okay, and okay, of course, this is just the geometric observation. It's important, but we need to answer it rigorously by using the limit. So what is the number? It's number 9a. So the function here, f of x equals to absolute value of x squared minus 1. Okay, and in this case, a equals to 1. So we have to check the limit of x tends to 1 of fx minus f1 divided by x minus 1. You have to check this exists or not. Exists or not. Or does not exist. Okay, so let us calculate the left hand limit and the right hand limit in this case. So limit x tends to, let us consider the right hand limit of fx minus f1 divided by x minus 1. Okay, so the limit x tends to 1 from the right. So here I have absolute value of x squared minus 1, and f1 here is 0, right? So 1 squared minus 1 is 0. So I have this one. And you'll see that if x is greater than 1, but it's close to 1, you'll see that x squared is always greater than 1. So absolute value of x squared minus 1 or x squared minus 1 is positive, right? So absolute value of x squared minus 1 is x squared minus 1 itself. Okay. In this case, we have limit x tends to 1 from the right, x squared minus 1 divided by x minus 1. That will be limit x tends to 1 plus of x plus 1. And that will be equals to 2, right? On the other hand, if I consider now limit x tends to 1 from the left of fx minus f1 divided by x minus 1, and this is limit x tends to 1 from the left of absolute value of x squared minus 1, and again f1 is 0. I have this one. But now if x is less than 1 and it's close to 1, you will see that x squared minus 1 is negative, right? So the absolute value of x squared minus 1 will be negative of x squared minus 1, okay, divided by x minus 1. And you'll see that here is negative of limit x tends to 1 from the left of x plus 1, and the result will be minus 2. So here we'll see that limit x tends to 1 from the right of fx minus f1 divided by x minus 1 is not equal to its left hand limit. Okay, not equal to its left hand limit. So limit x tends to 1 of fx minus f1 over x minus 1 does not exist. And the conclusion here, since this limit does not exist, then the conclusion is f is not differentiable at x equals to 1. or in this case, a equals to 1. A equals to 1. Okay. Okay. Any question or comment? The conclusion is f is not differentiable at a equals to 1. Okay. So if we continue to the next question here. Okay, so this is a piecewise defined function. So g of x equals to 1 minus x cubed if x is less than or equal to 0. And we have cosine x. Okay. The question is to check the existence of the derivative there. Okay. Okay. So let us write the definition of the function first, and then take a look at the limit here. Okay. So 1 minus x cubed if x is negative, and cosine x if x is positive. Okay, right. Okay, so let us calculate the, okay, from the previous question, it's better to start with, let's say, the left hand limit or the right hand limit at 0. Let us consider the right hand limit first of gx minus g0 divided by x minus 0. X minus 0. So in this case, I have limit x tends to 0 plus gx is, if x is greater than 0, okay, cosine x. Okay, and then g0 is 1, because here, if x equals to 0, then just substitute here 1 minus 0 cube is 1. It's 1 over x, and the value of the limit is 0, right? Okay. And then if I consider the left hand limit right now, gx minus g0 over x minus 0, that will be limit x tends to 0 minus, and then since x is less than 0, so the formula is 1 minus x cubed, and then g0 once again is 1, so minus 1 x, okay, limit x tends to 0 minus of minus x squared, right? And that will be 0. 1 minus x cubed minus 1 is minus x squared, x cubed minus x cubed divided by x is minus x squared. And in this case, we have its limit is 0. So the conclusion is, okay, first I will save it. So the conclusion is the limit is 0. Okay? The limit of gx minus g0 is 0, and its derivative at 0 is 0. First, I will save it. So in this case, the conclusion is, therefore, since the left hand limit and the right hand limit gives us the same number, namely 0, so limit x tends to 0 of gx minus g0 divided by x minus 0 equals to 0. And the final conclusion will be g prime at 0 equals to 0. Okay. Any question or comment up to this point? Question? Okay. So the next function is the okay. Here, recall that the symbol means the greatest integer that is less than or given number here. Okay. Okay, actually, you may take a look at the graph first at a equals to 1. So the graph of the function, okay, that will be floor of, what is the formula? 2 minus x, 2 minus x over x, okay? And the point is at what is a here? A is at 1. So you'll see that here the function is discontinuous. Okay, the function is discontinuous. So actually, we do not need to actually calculate the we do not need to calculate the limit in the definition of the derivative, but in fact, we just calculate the limit of the function itself, because you'll see that the function here does not have the limit there. Okay. So in this case, since the function is not continuous, then we may conclude that the function does not have derivative at this point at a equals to 1. Okay. But of course, let us answer this rigorously. So C h of x equals to the double bracket of 2 minus x divided by x, a equals to 1. Okay, so in this case, if I calculate h of 1, that will be 1, right? Okay, just 2 minus 1, it's okay, so I will write it 1 by 1, 2 minus 1 divided by 1. So the result is 1 over 1 and we 1. Okay, but now if we consider the right-hand limit and the left-hand limit, so we'll have limit, let's say, x tends to 1 from the left of h of x. So you'll see that here can be written as okay, limit x tends to 1 from the left of, okay, 2 minus x over x, the limit x tends to 1 from the left of x. And you'll see that if x tends to 1 from the left, so 2 minus x tends to 1 from the right. So in this case, we have the limit is always 1. And of course, limit x tends to 1 from x is 1. So the limit is 1. You just take, for example, x equals to 0.9. So you get 2 minus 0.9 is 1, 1. And if we round 1, 1 below, we get 1. So you'll get this one is 1. And on the other hand, if you consider the right-hand limit, x tends to 1 from the right of h of x, that will be limit x tends to 1 from the right of 2 minus x, once again, divided by x. In this case, limit x tends to 1 from the right of 2 minus x divided by x, divided by the limit x tends to 1 from the right of x. Here, you will see that x is greater than 1. So 2 minus x is less than 1. And then, of course, if we round this to the smaller integer, then the result is 0. Okay, so actually here it's always 0, and this is the limit is 1, the result is 0. So you'll see that the conclusion here, the limit at 1 does not exist. So the function is not continuous. And the final conclusion will be the function doesn't have the derivative at a equals to 1. Okay. So here I will write that the limit x tends to 1 of h of x does not exist. And so the conclusion is that f is discontinuous at 1. And the conclusion is f is not differentiable at 1. Okay. Okay, so it's not differentiable because it's discontinuous. All right. Okay, so for number 10 here, okay, I will. Okay, given the graph of the function f, f prime, and of double prime, then we should choose which one is the graph of f, which one is the graph of f prime, and which one is the graph of f double prime. Okay, if we start with the which one? If we start with the blue one here as the graph of f. So if you take a look at this, then if I draw the gradient of the tangent line, so if I draw the tangent line here, okay, the tangent line, the gradient of the tangent line is negative in this point. And at this point, the gradient is 0. Okay, and positive, positive, and it approaches 0, positive, positive, positive. So you'll see that if the blue curve is the graph of the function f, so which one is the graph of f prime? Is the brown one, right? Is because it's negative, and then at this point is 0, and then positive, positive, and it approach 0, and then positive, positive, positive. Okay. So the blue one is the graph of f, the brown one is the graph of f prime, and obviously here the graph of f double prime. To analyze the graph of f double prime, just simply start with f prime, okay, and then take a look at the gradient of f prime. Okay, the gradient of the tangent line of f prime is a positive, 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 and at this point, the gradient of the tangent line is 0. Okay, and in fact, f double prime is 0. Okay, and negative, 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 positive, and 0 once again. So it's negative there. So it's suitable. Okay. So the answer will be, this is f, this is f prime, and then this is f double prime. Okay. Okay. Any question or comment? Okay, any question or comment? Okay. So number 11, we should find a and b such that the function here, such that the function has a derivative or is differentiable at every point. You'll see that if x is less than or equal to 1, the function is a quadratic function. Obviously, for x is less than 1, the function is always differentiable because it's a quadratic function, polynomial. And similarly, for x is greater than 1, the function is a cubic function. It's once again a polynomial, always differentiable. So the key point here is to check the existence of f prime at 1, right? So differentiability of the function f at x equals to 1. Okay, so in this case, okay, just let us check the existence of f prime 1. Okay, go back. Fx equals to ax squared plus bx if x is less than or equal to 1, and x cubed minus 5 if x is greater than 1. Okay, now let us check the by using the definition. Okay, obviously we calculate the right hand limit and the left hand limit. Okay, if I consider the right hand limit, fx minus f1 divided by x minus 1. So in this case, I will have limit x tends to 1 plus of x minus 1, and then x tends to 1 from the okay, it's better from the left or the okay, so probably let us consider the left hand first. Okay, so in this case, I have ax squared plus bx minus f1 is okay, since is x is less than or equal to 1, just substitute x equals to 1 to obtain a plus b there. Okay, so in this case, I will have limit x tends to 1 from the left. Okay, so just collect a and b in this case. So I will have a multiplied by x squared minus 1. And then the next one, b multiplied by x minus 1. Okay, just ax squared minus a becomes a multiplied by x squared minus 1. Bx minus b becomes b multiplied by x minus 1. And then just divide it by x minus 1. Okay, you'll see that I can divide x squared minus 1 by x minus 1 to obtain x plus 1. And then I can divide x minus 1 by x minus 1 there. So in this case, I will have equals to limit x tends to 1 from the left, x squared minus 1 divided by x minus 1 is a multiplied by x plus 1, and then plus b. And then I will have this one equals to the limit is 2a plus b. Okay, so the left hand limit is 2a plus b. Okay, now we should check the right hand limit. Okay, because the limit exists if and only if it's left hand limit and the right hand limit are equal. Okay, so in this case, the right hand limit equals to tends to from the right fx minus f1 divided by x minus 1, and then I will have limit x tends to 1 from the right. Fx is x cubed minus 5, right? X cubed minus 5, and then f1 is once again a plus b minus a plus b divided by x minus 1. Okay, so the idea is that if I want to have the limit exists here, okay, so you'll see that if the limit of the denominator is 0, because it's simply just the limit of x minus 1 as x tends to 1 from the right, then the numerator should be also 0, right? So in this case, if this one exists, then I should say that limit x tends to 1 from the right of x cubed minus 5 minus a plus b is 0. So in this case, if I calculate the limit, then this becomes minus 4 minus a plus b equals to 0. So a plus b equals to minus 4. Okay, a plus b equals to minus 4. Okay. Okay, so in this case, if a plus b equals to minus 4, then I can continue the right-hand limit. Limit x tends to 1 plus of fx minus f1 divided by x minus 1 becomes limit x tends to 1 from the right, x cubed minus 5, and then f1 is a plus b, and now we know that a plus b is minus 4. So minus 4 divided by x minus 1. Then I will have limit x tends to 1 from the right of x cubed minus 1 divided by x minus 1. Okay. Okay, so the last term can be, okay, you may just divide x cubed minus 1 by x minus 1. So you'll have this one equals to limit x tends to 1 from the right of x cubed minus divided by x minus 1 is x squared plus x plus 1, okay, divided by x minus 1. So here you have limit x tends to 1 plus of x squared plus x plus 1. That will be 3. Okay. And in this case, okay, if I compare the left hand limit and the right hand limit, so the left hand limit is 2a plus b, right? And then the right hand limit is 3. Okay, so I have 2a plus where is 2a plus b equals to 3. And on the other hand, I have a plus b equals to minus 4. Okay, so if I solve this equation, then the solution a will be equals to 7 and b equals to minus 11, right? B equals to minus 11. Okay. So the value of a is 7 and the value of b is minus 11. Okay. Okay. Any question or comment? Yes.
Why did x cubed minus 5 equal to 0? Like
This one. The limit here exists, so and the limit of the numerator is 0, so the limit of the numerator should be 0. Okay. Or you may check this actually by the continuity. Okay, so to check the differentiability of the function at a certain point, then first we need the continuity. So if I want to check the continuity at 1, then I have to compare the left hand limit and the right hand limit of this, and the left hand limit is a plus b, and the right hand limit is minus 4, right? So if I consider the concept of the left hand limit and the right hand limit, the left hand limit is a plus b, and the right hand limit is minus 4, right? Then since we need the continuity, the left hand limit should be equals to the right hand limit. So a plus b equals to minus 4. You may also approach this problem by this one, by this argument. Okay. Any question or comment? Yeah, you may also use the left hand limit and the right hand limit. Compare this to have the information of and okay. Okay, so actually for number 12 and 13 and 14 is quite straightforward. For example, number 12, just use the formula for the derivative of the product of two function and also the ratio of two function. And number 13, you are not given the formula for of the function, but you are given the information of the derivative at the value of the function and the derivative at certain point, then just calculate it. So 12 and 13 actually you use the uh, you can use the formula for the derivatives. Okay. Either the sum of the function, the product of the function, and so forth. For number 14, there, here, just recall what is the derivative of cosine and sine. And then what happened if I combine other trigonometric function? Okay, just apply this. And number 15, okay, use the trigonometric identities and the rules for derivative. Okay. 16 and 17, the application of the derivative in finding the equation of the tangent line. 18 is the interpretation of the derivative in the problem of moving particle, and the moving particle is given here as a function of t, then the velocity is given as the derivative. So that's the 20, 21, 22 is just use the definition of the derivative. Okay. But we have to be careful, especially for 22b there. And yeah, that's probably that's it. Okay, we'll continue later on. Okay, I will stop and pause.